All right, today we are starting topic 15, so we're going to talk about topic 15-1. We're going to work on solving addition and subtraction equations. So you can go ahead and get the title in a notebook. Yes, in a notebook. I will be asking to see your notes. You could put in your I can statement. Our I can statement today is I can solve addition and subtraction equations. That's what we're working on today. That's what you should be able to do by the end of this lesson. So the first thing I need to do is review the word equation. Equation we've talked about all through the school year, but equation is a number sentence with an equal sign, and sometimes it has a variable. So I have a picture of what an equation might look like. We would have a first number plus a second number, and then we have this equal sign and we have an answer. Sometimes this plus sign would be a minus sign or a division sign or a multiplication sign. But we're going to have some sort of numbers, we're going to have an equal sign, and we're going to have an answer. Now this equal sign kind of serves as a balance, because if the stuff on this side doesn't mean the same same thing as what's on this side, then this equal sign would not work. The equal has to mean that this is balanced, that it's the same on this side as it is on this side. So if I put, let's try this out, if I had a 2 and a 3 and I had a 10 here, would this equal sign be okay? Well, we would have to add up 2 plus 3. Oh, 2 plus 3 is 5. So this 10 over here would make this equal sign not balanced, and so it would be not equal. Sometimes we have a variable, and we've talked before about a variable means a number that we don't know. So maybe we have a 3 here, we have some sort of variable here, I'll put an n for number, and over on this side we have a 12. Now our brain can automatically figure this out because we've worked so much with fact families. And we could say, oh, 3 plus something equals 12. But we're going to learn today how to go ahead and solve this if it might be a little more complicated. Okay? Okay, for this part you don't have to write down the words up here, but I do want you to go ahead and draw this box and be listening closely while I talk about this, what's going on here. This is talking about a field trip. We just took a field trip. 2 school buses take students on a field trip. Maybe to Camp Brewster. There are 31 students on the second bus. If the number of students on the first bus plus the number of students on the second bus equals 63, how many were on the first bus? All right, so I had you draw this picture here, and this is kind of our part whole. So we have a couple of key words here that help us to know how we're going to solve this. The first key word I see is plus, and the next key word I see is equals. So we're going to be doing some sort of adding, and we're going to get an equal sign. Well, I want to know the part wholes here. What are the 2 parts that make the whole? So let's see. Let's read over it again. And we're going to circle the numbers that we're dealing with. 2 school buses. Ooh, well, 2 is a number. 2 school buses take students on a field trip. There are 31 students on the second bus. Well, 31 is a number, second bus is a number. If the number of students on the first bus plus the number of students on the second bus equals 63, how many were on the first bus? So from this information we can get our whole. What is our total amount? Well, right here it says equals 63, so our total amount is going to be 63, so we're going to put a 63 in this box. Ooh, that was a crazy 3. We're going to put a 63 in this box. What are our 2 parts? Well, we've dealt with 63, so we can get rid of that one. Well, we have a first bus and a second bus. First bus, second bus. So then it says on the second bus, there were 31 students. So we're going to put 31 down for the second bus. Do we know how many students were on the first bus? Nope, we're not quite sure. When we're not quite sure of a number, we're going to put a variable. This time, I'm going to put a B for buses. I can form an equation out of this. Part math, part equals whole. Now, how would I go about solving that? I know a couple of different students might do something. We've been practicing guess and check. Sure, I could put a number in there. I could say, oh, maybe it's 30. 30 plus 31 is 63. Would my equation be balanced then? Well, I could go over here and do 30 plus 31. Boop. Uh-oh. I have 61, not 63. Well, my guess was 30, and how many away from my answer am I? I'm about 2 away from my answer. So, maybe instead of 30, I try 32. Let's see if that'll work. This is something called guess and check. First, I take a guess, then I check it out. Guess and check. I can totally do that. Good mathers are going to find a way. So, 3, 6. Perfect. Here's one way to do this. This is called a guess and check. So the guess and check would totally work, but we need to talk about some properties that might help us to solve these equations. So you need to write these properties down in your notebook. We have the addition property of equality, which says you can add the same number to both sides of an equation, meaning both sides of the equal sign. And then the subtraction property of equality says you can subtract the same number to both sides of an equation. And then we have an inverse, which we've talked about before when we talked about dividing fractions. We do the inverse or the opposite. So the operation, or, oh, that should say of math. No, it should say or math, sorry. The operation, that's a fancy word for math that undoes each other, I guess. So like multiplication, the inverse of multiplication is division. And for addition, the inverse of addition is subtraction. It goes the same, goes backwards. Could be the inverse of subtraction is addition, the inverse of division is multiplication. So go ahead and pause if you need to, write these down, and we're going to practice with them in just a little bit after you finish writing them down. No, really, it's cool. Go ahead and write them down. All right, so we're going to use the inverse to help us solve. This is a second way to be able to solve this equation. We have b plus 31 equals 63. We have the property, addition property of equality that we can use. Meaning I can add the same thing on this side of my equation as I do on this side, because there has to be a balance with that equal sign. So if I add 5 on this side, I have to add 5 on this side. That's how this equal sign balances out. Well, I want to make sure that I'm using this to help me. And to do that, I want to be able to get this number, or this variable all by itself. I want it to be all by itself, nothing else with it. Well, right now it has a plus 31 with it. You see how the 63 is all by itself over here? There's nothing with it. We're going to take this 31 and we're going to balance our equation by taking it away. We're going to do the inverse on this side, and that's where that subtraction property of equality comes in. Well, if I had add 31 over here, if I take away 31, this is going to cancel each other out. It's basically like, ooh, if I step 2 steps forward and then I step 2 steps back, I'm just in the same spot. And that's exactly what this is doing. So if I do that, I take away 31. The reason I do that is because I want to get this b all by itself. And so if I it has plus 31, I take away 31, it's going to leave B with plus Zippo. And we really don't even have to put that in there. We can just say B, because this number, this variable plus 0 is going to be just that variable. So it's going to leave that B all by itself. But it's also, because of that property of inequality, what I do on this side of the equal sign, I have to also do on this side of the equal sign. So I have to come over here and I have to subtract 31. Otherwise, it's not balanced. If I just came in here and I said, ooh, okay, I'll take away 31, but I didn't do it over here, then I'm just making things up. And in math, we can't just make things up. We have to have a reason. Remember all those mathematicians? Yes, they might have been lazy, but they had a reason for their laziness. So we had 3 take away 1 is 2. And then we have 6 take away 3 is 3. And when we do this math over here, there's no longer a 63 or a 31. Now we're left with 32. And we know that in our part whole that we had drawn before, where the total number was 63, the first bus had 31, the second bus is going to have 32, because we just used our properties of equalities to be able to balance it out. Let's try one more. Okay, so we're going to use our properties here. We have this variable of x. We have no idea what this number is going to be. I could do guess and check, but I'm really trying to help you guys do these subtraction and addition properties of equality to solve. It makes your steps so much quicker, and we're able to understand our equations. Remember, our equations have to be balanced, so we're going to look and see, well, how can I get this x all by itself? Well, right now I have a minus 12, so I want to get that x with a 0 next to it, so I'm going to do a plus 12 over here. I'm going to do the opposite, because if it's minus 12 degrees, what will it take to get it to 0? I'm going to need to add 12 degrees. So that's going to take that to 0. My x is all by itself. But what I have to do on this side, I have to do over here. So I'm going to add 12 over here. Oops, that's a plus. So 7 plus 2, 3 plus 1, and I have just solved for x. X is 49. We can also take this, put it back in there to test it out. 49 take away 12 will equal 37. All right, make sure this is all in your notebook. I'll be checking when you come to the table. If you get done with this video before you come to the table, log into the class Kick and try some of the problems on there. As always, happy mathing!